Okay, so in this video I'm going to have a look at vectors and scalars. So let's have a look first of all at different examples of vectors and scalars. So let's take scalars and vectors here. So we have let's have a look at some examples of scalars. So an example of a scalar would be something with magnitude only. For example, speed can be expressed in meters per second, kilometers per hour, miles per hour, and so on. Now, when you talk about speed, you would just say an object is going at 10 meters per second or 40 kilometers per hour and so on. You wouldn't give the direction. So when we talk about velocity, then we would talk about meters per second, for example, north, or meters per second south, and so on. So in other words, we would give the direction as well. Another example would be distance. So distance would normally be given in meters or kilometers and so on. So you could say that two objects are 10 meters apart, for example, or someone has moved a distance of 10 meters. Now, displacement, on the other hand, is a vector, and that gives the distance in a particular direction. So you would say someone has moved, for example, 10 meters north, or 10 meters south, and so on. Mass is normally measured in kilograms, and that would be considered a scalar, so you wouldn't normally give a direction for mass. And temperature is another example of a scalar. You would just give its magnitude only, there's no direction there as such. Another example of a vector would be force. Normally you would say that you are applying a force of, let's say, 10 newtons in a particular direction, east or north or south or whatever the direction is. Another example of a vector would be acceleration. So again, that's normally measured in meters per second squared, and you would also give the direction as well. So again, you can say east or north or south or whatever the direction happens to be. Now, when we look at vectors, we normally represent vectors using arrows. So, for example, I could represent a force of, let's say, 10 newtons with this arrow here. So this would be my vector, my force vector. What we can do is represent, in actual fact, what we call it is an IJ plane. So it has a horizontal axis called the I-axis and a vertical axis called a J-axis. So this vector here, for example, could be represented like this from the origin. So this would have a magnitude of 10 newtons, and what we can do is break that down into its I and J coordinates, if you like, or its I or J components. So we would need to come out here a certain distance in the I direction and then come up along this way in the J direction. So how do we do that? Well, if we look at our vector here, what we can do is bring a vector out here in the I direction and bring a vector up along here in the J direction. And let's say this angle here, for example, is, let's say, 30 degrees. So we're applying a force of 10 newtons at an angle of 30 degrees to the horizontal to an object. So this angle here would be 30 degrees. Now, if we take that this is a right angle here, what we can do then is look at let's say the cos of 30 degrees is going to be this component here. Let's call it x and let's call this y for the moment. The cos of 30 degrees is going to be x over 10. So in other words, x is just going to be 10 cos 30. So I can replace this here, this x here, with 10 cos 30. And I can also similarly do sine of 30 degrees, and what you'll find here is that this component here will be 10 sine 30 degrees. So for example, sine of 30 degrees is just going to be my y over 10, so y is just going to be 10 sine 30 degrees. Now just bring that on a little bit further, we can see here that 10 cos 30 is going to be, that's just going to be 10 times the cosine of 30 is root 3 over 2, so that's root 3 over 2 multiplied, so that's just going to be my x component is going to be 5 root 3. So x is 10 root 3 over 2, so x is just going to be 5 root 3. So what I can say now is that this distance out along here, now is just going to be 5 root 3 I, and this distance up along here then, if we do that, we get 10 sine 30. Well, sine of 30 is just a half, so we just get 5. So our y direction here is just going to be 5. So this distance up along here, this vector, this component vector up along here, is just going to be 5j. So what we can say then is our magnitude of 10 newtons at an angle of 30 degrees in the to the positive direction of the y-axis here can be written as, so 10 newtons at 30 degrees to the positive direction to the y-axis can be just written as 5 root 3 I plus 5j. So this represents our 10 newtons, our magnitude of 10 newtons. And so what you can do just to double check that is, really you're just using Pythagoras' theorem here. This particular vector here is written in the form AI plus BJ. So to find the magnitude of this vector here, we would do the modulus of the vector, and that's just equal to the square root of a squared plus b squared. So if we were to do that here, the magnitude of 5 root 3i plus 5j, that's just going to be equal to the square root of 5 root 3 squared plus 5 squared. And if we do that, we get the square root of 3, 5 5s are 25, and then 3 25 75 plus 25 here, 5 squared is 25. That gives us the square root of 100, which is 10 newtons, and that's what we started with. We started originally with a magnitude of 10 newtons. Okay, so that's it for an introduction here to scalars and vectors.